All right, lesson 12.5, angle relationships in circles. So we have a theorem, it doesn't really have a name, but if a tangent and a secant or a chord intersects on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. So a little vocabulary review. BC, this is our tangent line. That's the tangent line. It's where it hits the circle at one location and then continues on away from the circle. Then we have a secant, which is BA, which starts a point on the circle and goes through the circle, hits another point on the circle, and then continues on forever. So it's an actual like a ray or a line, not a segment. Now it could be a segment, and then we would have a chord instead. So we have our tangent, and we have our secant, and that makes an angle right here. This angle right here, ABC. And just like in the last video where you had the intercepted arc is always double the amount of degrees as the inscribed angle, the same thing applies here. That if this was an arc of say 80 degrees, then this inscribed angle is half of it, which would be 40 degrees. Just like an inscribed angle. This is an inscribed angle, they're just not calling it that. So problem 1, find each measure. So our first one they'd like us to find is BCD. So they want us to find this angle right here, BCD. Well, we can see that its intercepted arc, B all the way to C, this arc right here is 142. So angle BCD should be half of that. So 142 divided by 2 will be 71 degrees. So we know this right here is 71 degrees. The next thing they'd like us to find is the measure of the arc ABC. So they want us to find ABC. So they want us to find this entire arc right here. Well, if we look carefully in the picture, we'll see that we have this 90-degree angle here for ACD. So the inscribed angle is 90 for the arc ABC. So that means if we just look at the blue arc, doubling 90 is 180 degrees from there to there. All right, so find each measure. So the first one they'd like us to find is the measure of STU. So they want us to find this angle right here. This is the one they want us to get. So we'll just call it X degrees. Well, they give us the arc from S all the way to T being 176 degrees. So its inscribed angle would be half of 166. So that's 83 degrees. All right. And then they want us to find the arc measure for SR. So they want us to find this arc measure here. And its inscribed angle is 71 degrees. So that means its arc would be double of that 71 degrees. So 71 times 2 is 142 degrees. So what these last two problems are doing is going over the same concept as the last video, but the difference is now they're providing you with a tangent line and a secant or chord to create the inscribed angle. That's the only difference. It's exactly what you were just doing in the previous video. Okay, now this is new. If two secants or chords intersect in the interior of the circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. So the best way to think about this is it's finding the average. As an example, if, say this was 80 degrees, arc AB, and CD is, I don't know, 60 degrees. Well, all you're doing to find angle 1, this angle right here, is that you add the two numbers together and then just divide it by 2. So 80 plus 60 is 140, divide it by 2, and you get 70. So you know that angle 1 is actually 70 degrees. And since angle 1 here is a vertical angle of this right here, you also know that that's 70 degrees. So if you have two chords or two secants intersecting somewhere in the circle, if you take the two arcs that are shown, add them together and divide by 2, you'll find what those vertical angles are. All right, problem 4 wants us to find the angle measure RNM. So they want us to find this angle right here. Well, they made this problem a bit more work than the last one. So we would always love for them to give us the arc length here and here, so we could just add them together and divide by 2 and get the answer right away. But this time, instead, they decided to give us the arc length here and the arc length here, which is fine. We can then find angle RNP. We could figure out what this angle is right here, and then use that to figure out what x is. So by using the formula that I showed you in the last slide, if we take the 90 degrees plus the 225 degrees, add them up, and then divide it by 2, we're going to get 316 over 2, and then we divide it by 2, we get 158 degrees. So right here is 158 degrees. Well, if we look carefully at MP, that's a straight line. Straight lines make 180 degrees. Well, we know that from here to there is 158, and so if we go 180 minus 158, we'll find out what that angle is. So 180 degrees minus 158 degrees is 22 degrees. And that is the angle measure of RNM. All right, so we have another theorem. It doesn't have a name, but you see we have 3 different scenarios. We are given a picture with a tangent line and a secant line making an angle outside of the circle. We have another situation where we have 2 tangent lines making an angle outside of the circle. And then we have a situation where we have 2 secant lines making an angle outside of the circle. Now, it doesn't matter what scenario you come across, whether it's a 2 secant lines, 2 tangent lines, or a tangent and a secant, if it makes an angle outside of the circle, we can use the formula below. And even though they have different letters, it's the exact same formula. Basically what it's saying is this: if you take the arc here and subtract it from this arc here, divide it by 2, you'll get this angle measurement there. So if in the middle one, if you have 2 tangents, if you take this arc here, this angle measurement, that arc measurement, and then this arc measurement here, subtract them, and then divide by 2, you'll get this angle measurement. Same thing here. If you take this arc length and then you take this one, you subtract them, divide it by 2, you'll get that angle measurement right there. So it doesn't matter what scenario you get, you do the same thing every time. So let's take a look at an example. It wants us to solve for x, and by solving for x, we're really finding the angle measurement of RPS, so we're finding this measurement right here. So we just follow what we do. We take the big arc length here, 174 degrees, subtract this arc length right here, which is 98 degrees, and then we just divide it by 2. So 174 minus 98 is 76 divided by 2. So we get 38 degrees. So x is equal to 38 degrees, or you could say that the measure of angle RPS is 38 degrees. All right, so for this problem, they want us to solve for x again, which means you're trying to find angle EFG. But this time they only give us one arc measurement. They give us the interior one here of 132. Well, we got to figure out what this one is here. Well, you should know that a circle is 360 degrees all the way around. Well, the blue arc is 132. That means what's left over would be, so 360 minus 132, what's left over would be our orange part. So 360 minus 132 is 228. So this right here is 228 degrees. So now we can use our information to figure out what the x is. So if we go ahead and say 228 minus 132, then we just divide it by 2. We'll find out that the angle measurement, 228 minus 132, gets us 96. Divide it by 2, you get 48 degrees. So this right here is 48 degrees. You're always going to put the larger arc, the exterior one, first, and then subtract the smaller one, which will be the interior one. I'm calling it interior mainly because it's closer to that angle that we're trying to find. Problem 7, solve for x. So it's very similar to the problems we've been doing, but this time, instead of having to find the angle out here, now they want us to find one of the arcs. So we're going to work it like we have in the past, but we're going to fill in what we know and put x where we don't know. So normally the angle is what our two things equal. So we usually have 83 minus whatever this arc, the smaller arc here is, we'll just call it x, divided by 2. But it always ends up equaling our angle on the outside, which in this case is going to be 25. Now we have our setup. So if we go ahead and multiply both sides by 2, because we want to get rid of this fraction, we're going to be left with 83 minus x equals 50. We're going to minus 83, and we're going to get negative x equals negative 33. We're going to divide both sides by negative 1 because we want our x to be positive. And we're going to get positive 33. So the arc KM, the measure of the arc KM is actually 33 degrees, which is that little x right there. All right, problem 8, find arc measurements. They give us 3 different ones they want us to find. So the first thing they're looking for is arc A, D, all the way to B. Now we can see that its inscribed angle for that arc is 110 degrees, which means we would double it to find the arc length. That's 220. So always remember that idea that the inscribed angle is half of the arc length. Or you can say that that arc length is going to be double the angle measurement of the inscribed angle. So the next part is measure arc AD. Well, if we know from A all the way to B is 220, and we know from D to B that arc length is 160, if we subtract those two measurements and get 60 degrees, we know that DAD would be 60 degrees, because 60 degrees plus 160 degrees is 220 degrees. All right, the measure of AF. So keep in mind, once again, that a circle is 360 degrees. Well, we know that this section here is 48 degrees. We know this section right here is 220 degrees. So if we go ahead and say, well, if we know 360 total is a circle, if we subtract away the 220, and then we subtract away the 48, what's left over is the arc AF. So 360 minus 220 minus 48 is 92 degrees. All right, problem 9, finding arc measure. This one is a bit more complicated. It requires you to use a bunch of your knowledge from this lesson. So they want us to find YZ, this arc right here. But we can't figure it out just by looking at it. So we have to do a little bit more investigative work. So a few things I'm going to kind of take a look at is, I know this right here is 113. I'm going to go ahead and figure out what these angle measurements are. So YW is a straight line, and I know 113 of it. So the other part would have to be 180 minus 113 is 67. So 180 minus 113 is 67 degrees. So this right here is 67 degrees. And because of vertical angles, I know this right here is 67 degrees. Now, since I know this angle measurement here, and I know its arc right here is 68, I want to figure out this arc right here that I'm going to highlight in red. I want to find that next. So to do that, I'm going to remember that these two arcs, the red and the blue, should add up together and then divide by 2 to get 67. So 67 should equal 68 plus the red arc, which I'm just going to call x, divided by 2. Remember, the blue arc and the red arc should always average to give us this angle right here, the 67. So I'm going to go ahead and solve that equation. I'm going to multiply both sides by 2 to get the fraction, get rid of the fraction. So 68 plus x is left, and then 67 times 2 is 134. I'm going to minus the 68 to both sides. So x equals 66. So now I know this right here is 66 degrees. Now that I know that that arc here is 66 degrees, I can use it plus this angle being 49 degrees. I can use that information to help figure out arc YZ. So if I go ahead and say 49 is equal to YZ, that arc, minus 66, all divided by 2. So remember that big arc minus the smaller arc here, when you subtract them and then divide by 2, it should equal that angle outside of the circle. So I'm going to go ahead and multiply both sides by 2. So 49 times 2 is 98 equals the arc YZ equals 66. Gonna add the 66 over. And so the arc YZ is equal to 98 plus 66, which is 164 degrees. And you found it. This one's a bit trickier. It does require you to use both of the formulas you learned to figure out this problem.